number 3, given fx is equal to x square minus 6 over x, find the coordinate of stationary point and then determine whether it is a relative maximum or minimum. So the first step is to find the first derivative. So we have f prime is equal to 2x plus 6 over x squared. And how to find the stationary point? We always equate our first derivative with 0. Okay, so you solve this equation to get the value of x. So I multiply both sides by x squared. So I get 2x cubed plus 6 is equal to 0. And then x cubed is equal to negative 3. And x is equal to negative 3 to the power of 1 over 3. Or by using calculator, you get x is equal to negative 1.442. Okay, and then you substitute the value of x into the function fx to get y. So y is equal to fx. Okay, so you substitute the value of x, negative 1.442 square minus 6 over negative 1.442. And then you get y is 6.241. So as a conclusion, we may conclude that negative 1.442, 6.241 is the stationary point. Okay. Okay, the next step is how to determine whether the point is this point is maximum or minimum. So we need to do the second derivative. So from the first derivative, we differentiate again to get the second derivative. So f double prime is equal to 2 minus 12x to the power of negative 3. And then we substitute the value of x into the second derivative. So when x is equal to negative 1.442, our second derivative will be 2 minus 12 negative 1.442 to the power of negative 3, we get 6.002. And 6.002 is a positive value which is greater than 0. And there we may conclude that the point is relative minimum. And don't forget to write your conclusion. Negative 1.442, 6.241 is the relative minimum. Part B number 1, given z1 is equal to negative I and z2 is equal to 2 plus I z3. Okay, so question A, express z1 square and z2 bar in the form a plus bi. z1 square negative I times negative I, so we get I square, and I square is equal to negative 1. Next, z2 bar. Okay, z2 bar is a conjugate of z2, so don't forget to change the sign. So from positive it becomes negative. So z2 bar is equal to 2 minus I z3. Number 1, part B. From part A, okay, find W is equal to z1 square plus z2 bar over z1. So we already know z1 square. z1 square is equal to negative 1. And z2 bar from part A is equal to 2 minus I z3. Okay, over z1. Okay, so z1 is equal to negative I. We simplify the numerator part, we get 1 minus I sub 3 over negative I. So please change W in the form of A plus BI. So what you have to do is to multiply by conjugate of the denominator. So this is negative I. The conjugate is positive I. So we multiply by the conjugate, positive I over positive I. And then we expand. We get I minus I square sub 3 over negative I square. And don't forget to substitute I square with negative 1. So you get I minus negative 1 sub 3 over negative times negative 1. Your W will be sub 3 plus I. Okay. The next part, hence, find modulus of W and argument of W. Okay. So formula for modulus W is equal to sum of A square plus B square. In this form, A plus BI. So by comparison, A is equal to sub 3 and B is equal to 1. So modulus of W is equal to sum of A square. So it means that sub 3 square plus B square 1 square. So the answer is 2. Okay. The last part will be argument of W. To find the argument of W, please draw the Argand diagram first. Okay. This one will be your real part, and y-axis will be your imaginary part. So we have sub 3 plus I, so it will be somewhere here, sub 3 1I 1. So W will be at first quadrant. So for the first quadrant, argument for W is equal to alpha, and alpha is equal to arctangent modulus B over A. So we just substitute the value of B and A. Therefore, argument of W will be arctangent modulus B over A. B is 1 over A sub 3. And please make sure that your calculator in radian mode. So your answer will be pi over 6, or in decimal places 0.524 radian.
Okay, so for question number 4, we have the question for chapter functions. Alright, so this function that we are given is function of ln 2x plus 1. Alright, so we have to remember that for this case, okay, for question A, we want to state the domain and range of fx. So for the basic case of a ln function, okay, so if we sketch our graph, this is how our graph will look like. Okay, this is our function for ln x, okay, y equals to ln x. And in this case, our domain, okay, so let us check the domain for the basic function. That is from 0 to infinity. 0 as our asymptote, and the range will always be negative infinity, infinity. Okay, so that is all real numbers for the range of this function. So in this case, if we look at this function that we have fx equals to ln 2x plus 1. Okay, so our range will always be negative infinity to infinity for any ln function. Let's just write that down first. Alright, and then for the domain, you have to check the value inside this bracket. Okay, so we have y or fx equals to ln 2x plus 1. Okay, so our value is 2x plus 1 not equals to 0. Alright, so we're gonna have x is not equals to negative 1 over 2. So that will be our domain, negative 1 over 2 infinity. Okay, so it must be greater than, right? So sorry, over here it must be greater than 0. Okay, not equals to, it must be greater than 0 because it also cannot take the value for negative. Alright, so negative 1 over 2 and infinity over here. So that is the domain and range of this function. Alright, now if you look at the second part of this question, you have to find the inverse of fx, okay, and then find the domain and range. Alright, so to get to the inverse of fx, okay, so we will use the definition of a composite function, f times f inverse of x, okay, that is equals to x. Okay, alright, so having this, so for our function of fx, we have ln, alright, and then we are going to substitute 2, okay, and then f inverse of x plus 1, that is equals to x. Alright, and then removing this ln, we will have 2f inverse of x plus 1 is equals to exponent x. Okay, so to get to our f inverse of x, we will have over here exponent x minus 1 over 2. Okay, and then for the next part of the question, we are also asked to write down the domain and range for the inverse. Okay, so the trick over here is we understand that, okay, when we have our fx, okay, and then our f inverse of x, f inverse of x, okay, so the domain and range is the opposite. Alright, so the domain and range is the opposite. So domain over here, okay, domain of f over here and range of f over here, and here is the domain and also range. Okay, so if we have a domain for our fx already, that will be the range for our inverse. Okay, and then the range for our fx, okay, will be the domain for our inverse. So over here, you can just directly write down that we will have, okay, so check from our fx, so the domain, now we want to write down the domain of f inverse of x, okay, f inverse over here, domain of f inverse, that will be the range of our fx, so that will be our negative infinity and then infinity over here. Alright, and then the range of f inverse of x, that will be our domain from our domain over here, so that will be negative 1 over 2 infinity. Okay, so can you see that I just switch these two terms? Okay, so the range will be the domain, and then the domain will be the range for the inverse function. Okay, and then for the next part over here, we are also asked to find, hence find the value of x, okay, value of x for which f inverse x is equals to 0. So if f inverse of x is equals to 0, meaning that we are taking this function over here, exponent x minus 1 over 2 equals to 0. So we will have that exponent x is equals to 1. Alright, because okay, so by rearranging, we will got exponent x equals to 1, and then we will have that x is equals to 0. So that is for part B. Okay, so we have already obtained the value for x when f inverse of x equals to 0. Now to sketch for this graph, okay, always remember that just now I already told you that this is the basic graph of ln x. Alright, and if we recall the basic graph for our exponent function, or the inverse of this one, that will be something like this. Okay, it will go upwards like this. Okay, so this one is y equals to exponent of x over here. Okay, so this will be our function, our graph. Right, so we look at this one. This is our f inverse of x. Okay, the first one, this is our f inverse. Okay, let me highlight that. Okay, this is the graph for f inverse of x. Okay, the one that curve outward like this. Okay, and then the other one, this one, if I take that in green, for example, this is the graph for f. Okay, so if you look at these two lines closely, we have this asymptote line. Okay, so if we take from function of f, the asymptote line is at negative 1 over 2, because our domain start from negative 1 over 2 to 0. Okay, and then for the inverse function, we have that the range is from negative 1 over 2 up to 0. So I hope this one, sorry, so I hope you are clear with this sketching of this graph. Okay, and the most important part is you also need to show that you have this line y equals to x over here. Okay, so please look closely at this graph and try to sketch your graph. Alright, so for this question, question number 5, part A. Alright, so we want to check for first, we're given this function of gx, right, defined by two functions, two part. Okay, gx is equals to 3 when x is in between 2 and 8. Okay, and then this absolute value of 8 minus x over x minus 8 plus k when x is greater than 8. Okay, so now we need to find this value for k such that gx is discontinuous at x equals to 8. Alright, so this is what we are given over here is the case where it is discontinuous at x equals to 8. So we understand that if it is continuous, the first the rules that we need to follow is g of 3 is equals to the limit for x approaching, sorry, g of 8 over here. So the function of g when x is equals to 8 is equals to the limit of x approaching 8 for gx. So this is when it is continuous. So now we are looking for when it is discontinuous. So if it is discontinuous, meaning that now the equation that we are looking for is g of 8 is not equals to the limit of x approaching 8, okay, for gx. Alright, so in this case we only have x approaching, we only have two different functions, two different parts, right? So for g of 8, this also meaning this is also the same value as x approaching 8 from the left. Okay, so this one x approaching 8 from the left. Alright, so for this one on the right hand side, we will take this one as x approaching 8 from the right hand side, so that we can use the second part of gx over here. Okay, so for the function when g of 8, okay, the value is equals to 3 over here. So if this is equals to 3, okay, we want to check for, so this side we will use this function, okay, limit x approaching 8 from the right. So this is the function that we are looking for, 8 minus x and then x minus 8 plus k over here. Okay, so when we have it like this, so what we're gonna do next is, okay, this left hand side will just stay the same, so pretty much we will operate with the value for the right hand side. Okay, so we will have over here limit of x approaching 8 from the right. Okay, so if it is from the right over here, we can change that to negative. Alright, and then we have 8 minus, okay, so if you put 8 minus x over here, okay, so we will take the negative value, right, and then this one is divided by x minus 8, okay, and then we have this plus k over here. Okay, so the next line that we have is x is 3 is not equals to, so if we substitute this, if we rearrange this value, we will have over here, okay, so if we double check here, we will get that. Okay, so kalau if we factor out negative x over here, okay, we can simplify this so that this will just become 1 plus k. Okay, so if you look at this one, you factor out again negative. Okay, this one, the first one, we factor out negative from this absolute value function over here. Okay, and now if we factor out negative again, so that you will get, okay, negative of negative again. Okay, so that will be a positive actually. How do I write this? So that will just be a positive of x minus 8 over here, and then we divide by x minus 8, okay, plus k. So I factor out again negative over here. Right, so we are now just left with the limit of x approaching 8 from the right. This will just be 1 if we simplify this. So we have 1 plus k. Right, so if you look at this function that we are left with over here now, we don't have any more term of x, so that is just gonna be 3 is not equals to 1 plus k. Alright, and if we rearrange this, k is not equals to 2 over here. Alright, so this is the value of k, values of k. So k can take all values except for 2 because it is discontinuous at x equals to 8. Right, so this is for question 5 part A. Now, if we look at question part B, so we want to determine whether fx is continuous at x equals to 3. So if you still remember, we have three conditions for continuity. First, you have to check f of x must be, let's say the continuity we want to check is at c. Okay, so f of c must be defined. Okay, that is the first condition. Okay, and then the second one, okay, so the limit of fx, okay, when x approaching c from the left must be equals to the limit of x approaching c from the right of fx. Okay, so this must be equal so that exists, so that the limit of x approaching c of fx exists. Okay, and then the third one, the third condition that it must satisfy is f of c must have the same value with the limit of x approaching c for fx. Okay, so these three conditions that we need to check. So let's check this one by one for the continuity of fx at x equals to 3. Alright, so part 1 over here, we need to check that it is defined. Okay, so f of c is defined. So f of 3, f at 3 is defined. So f of 3 is this part, the second part of fx. So that is equals to negative 6 over here. Okay, so this one is equals to negative 6. And then the second condition, right, we will check this one if limit of f of x when x approaching c exists. So we will check the limit from both sides. Okay, x approaching 3 from the left of fx. Okay, and then we will check from the right. So from the left of fx, that is this first function. So we will have limit of x approaching 3 from the left, and our function is 9 minus x square over here, and then divided by x minus 3. Okay, so we can actually factor this out. So we will have um, 3 minus x over here. Okay, and then we will have 3 plus x. Alright, and that is divided by x minus 3. Okay, to simplify this further, we can actually factor out the negative sign so that we can simplify. Okay, so we factor out negative. This will be left with 3 plus x. Okay, so we can simplify this 3 minus x with x minus 3 down here by factorizing negative over here. Okay, then we will get this value. If we substitute with 3, so we will get that this will be negative 6 over here. Okay, so we check the second condition. So limit for x approaching 3 from the right of fx. Okay, and that function is given by limit of x approaching 3 from the right, and this function is the last function down here. So we have 162x, right, minus 54x square, and then divided by x cubed minus 27. Okay, so to simplify this, okay, we can see that we can actually factor out 54 from the numerator. So we will get x approaching 3 from the right. Factor out 54, we will get over here 162 divided by 54. Okay, actually we can factor out 54x over here. Okay, so 54x, alright, then we will have over here 3 minus x. Right, and then for the denominator, we can also factor this, as in factorizing this, we can get x minus 3. Okay, and then over here we will have x squared plus 3x plus 9. Okay, so you have to factor out the cubic function down here on the denominator. So now we will have that limit of x approaching 3 from the right. So over here, to simplify 3 minus x and x minus 3, okay, so to simplify these two terms, you actually need the negative sign, right? So this one and this one, you have to factor out the negative sign first for the numerator. So you will get negative 54 x over here. Okay, negative 54x for the numerator. Right, so having this, now for the denominator, we will have that is equals to x squared plus 3x plus 9. Okay, so we have already simplified, and you need to add the negative sign. You factorize out negative first so that we can simplify 3 minus x with x minus 3. Okay, and then after that we can do direct substitution over here, and if we substitute 3 over here, you will get negative 6 also. Okay, so substitute 3, you will get negative 6. And then finally, you can check that, okay, we now have, okay, let me just separate this first. Okay, so now we already have that for the second condition, we have the limit of x approaching 3 from the left of fx, right, is equals to the limit of x approaching 3 from the right of fx, which is equals to negative 6. Okay, and then we can say that the limit of x approaching 3 of fx is equals to negative 6. Okay, and then for the third condition, alright, the third condition over here, we have that we can already check that f of 3 is actually equals to the limit of x approaching 3 of fx. Okay, and that is equals to negative 6. Okay, so we can say that therefore fx is, okay, so we can say that it is continuous, okay, at x is equals to 3. Okay, so this is our final answer and the solution for question number 5 part B. Okay, so always remember these three conditions, and then we will just check the continuity by following the three conditions. Right, so this is satisfied, it is continuous.
Assalamualaikum warahmatullahi wabarakatuh dan juga salam sejahtera. Jadi kita akan tengok nombor 6 untuk soalan maths text. Jadi diberi x square y sama dengan sin 2x square tambah pi. So we have to show that you got this after you differentiate. Okay, so now we are going to solve 6a first. So for question A, I'm going to start with the original equation, which is x square sama dengan x square y sama dengan sin 2x square tambah dengan pi. Okay, so yang sebelah sini kita akan differentiate menggunakan product rule. Jadi u kita adalah x kuasa 2, u prime adalah 2x. Okay, v kita adalah y, so v prime kita adalah dy dx. Okay, kemudian saya akan substitute ke dalam formula product rule, which is u and then v prime dy dx tambah dengan v, which is y, and u prime iaitu 2x. Okay, kemudian yang sebelah kanan, differentiate sign, kita akan dapat cos. The answer is cos. Okay, kemudian don't forget angle tu kena ada. Jadi 2x square tambah dengan pi, and then we can differentiate the angle. Okay, so differentiate 2x square tambah pi akan dapat 4x. Okay, pi adalah constant, so differentiate pi dapat kosong. Okay, so kita akan pindahkan dia ke depan. Jadi kita akan ada 4x cos 2x square tambah dengan pi. Okay, so kita kemaskanlah sikit. Ini sama dengan x square dy dx tambah dengan 2xy. Okay, so kita kena differentiate once again. Okay, we have to find second order differentiation. Alright, so once again, this one we are going to do product rule, okay, to differentiate. And this one also you have to use product rule. And also for this, you have to use product rule. Jadi 3 kali product rule that we have to do. Okay, so we are going to start with the first one. Okay, this one first. Okay, so our u is x square. Our v prime is d square y dx square. So you copy x square and then you differentiate dy dx. Okay, plus with, okay, you differentiate, you copy dy dx and you differentiate x square pula. So you get 2x. Okay, so finish for the first expression. And then we are going to differentiate this one, okay, using product rule as well. Okay, so plus with our u is 2x and our v prime, okay, differentiate y, so we get dy dx. Plus with our v, which is y, and then our u prime, which is 2. Okay, so finish. Differentiate this expression. And then we are going to differentiate the one on the right hand side, okay, using product rule as well. Okay, so our u is 4x. And then we have to differentiate our v. Okay, this is our v. Okay, so differentiate cos, we are going to get negative sign. And then don't forget the angle, which is 2x square plus pi. And then you have to differentiate the angle, so we get 4x. Okay, so u v prime plus with v u prime. Our v is cos 2x square plus pi, and then u prime is 4. And then I'm going to rearrange. So now we have x square d square y dx square plus with 2x dy dx Okay, plus with 2x dy dx plus with 2y equals to negative 16x. Okay, because we multiply 4x here and 4x here, jadi negative 16x square, we got it. And then we have sine 2x square plus with pi. And then we have plus with 4 cos 2x square plus with pi. And then this one, okay, we can substitute with x square y from the question, okay, which is x square y equals to sine 2x square plus with pi. Okay, so we substitute with x square y. And then let's check the one that we want to prove. We only have this term on the right hand side. Okay, so I'm going to leave only that term on the right hand side. Okay, so this term, I'm going to bring it to the left. Okay, bring to left hand side. Okay, and leave only this according to the one that we want to show. Okay, so let's do it. So we have x squared d square y dx square here. And then 2x dy dx plus 2x dy dx is 4x dy dx. And plus with 2y plus with 16x to the power of 4y equals to 4 cos 2x square plus with pi. Okay, x to the power of 4 I obtain from when I multiply x square and x square, so we get x to the power of 4. And then let's check it out, the one that we want to prove. Okay, so this is the expression. Okay, so from here we can factorize y. So we have x squared d square y dx square plus with 4x dy dx. And then I'm going to factorize 2y. Okay, so we have 1 plus with 8x to the power of 4 equals to 4 cos 2x squared plus with pi. And then let's rearrange. Okay, so rearrange becoming this. But before that, okay, I seem to miss this x here. Okay, we have x there. Okay, sorry. Okay, so this one is shown. So now let's do question B. We want to show that our dy dx is equals to this. So first we have to find dx dt. Okay, this is our x, so differentiate. We are going to get 2 plus with t to the power of negative 2. Okay, so let's equalize the denominator. So we have 2 plus 1 over t square. So when we equalizing the denominator, we get 2t square plus 1 over t square. Next, let's find our dy dt. So this is our y. So dy dt is 2 minus t to the power of negative 2. Okay, and then let's equalize the denominator. We have 2 minus 1 over t square. Okay, when I equalize denominator, we have 2t square minus 1 over t square. And then to find dy dx, okay, dy dx equals to dy dt, okay, multiply with dt dx. So this is our dx dt, so we have to reciprocate dx dt to obtain dt dx. So we have t square over 2t square plus 1. And then we can cancel t square and t square here. And lastly, we are going to obtain 2t square minus 1 over 2t square plus 1. Okay, so that is our dy dx shown. Okay, next question is to find d square y dx square in terms of t. In terms of t first, hence show that d square y dx square is equals to 8 over y cube. Okay, so to find d square y dx square for parametric, first we have to differentiate our dy dx with respect to t, and then you have to multiply with dt dx. Okay, so our dy dx just now is this, so we have to differentiate this using quotient rule. Okay, so the formula for quotient rule is v, which is 2t squared plus 1, and then u prime, which is 4t, minus with our u, which is 2t squared minus 1. Okay, v u prime minus with u v prime. Our v prime is 4t. Okay, divide by v square. Okay, so we have 2t squared plus 1 square. So that is the formula for quotient rule. But don't forget to multiply with our dt dx. So our dt dx is t squared over 2t squared plus with 1. And now let's simplify. So when you simplify the numerator, you can try plus, minus, expand everything. So you are going to get, it is 8t cubed. Okay, 8t cubed over 2t squared plus 1 to the power of 3. Okay, this is what we are going to obtain after you simplify and multiply. And then we want to show that d square y dx square is equals to 8 over y cube. Okay, but before that we have to look at what is our y cube. Okay, our y is equals to 2t squared plus 1 over t after I equalize the denominator. Okay, this is our original y, okay, which is 2t plus with 1 over t. And then when I equalize denominator, this is our y. And then, so that means our y cube is equals to 2t squared plus 1 over t to the power of 3. Okay, this is our y cube. And then our 1 over y cube is equals to t over 2t squared plus 1 to the power of 3. Okay, which is equals to this. Okay, which is this. Okay, so this is actually 8 times with 1 over y cube. Okay, so it is equals to 8 over y cube. Okay, so shown. Assalamualaikum dan salam sejahtera. Kita tengok nombor 7. Given a right circular cylinder with height 2h and radius is r equals to square root of a square minus h square, which is inscribed in a sphere of fixed radius a. Show that the volume is v equals to 2 pi a square minus h square times h. Jadi kita akan selesaikan soalan A terlebih dahulu. Okay, jadi formula volume bagi silinder adalah pi r square h. Kemudian kita akan gantikan r yang diberi dalam soalan adalah punca kuasa a square minus h square. Dan juga h daripada soalan adalah 2h. Jadi kita gantikan ke dalam formula volume. Okay, so kat situ dah shown lah yang dia nak show tu. Cuma 2 tu bawa ke depan. Okay, kemudian kita nak cari first derivative dengan second derivative. Saya akan expand lagi untuk memudahkan kita differentiate. Okay, yang tu saya expand. And now let's find d with h. Differentiate v with respect to h. So we are going to get 2 pi a square. And then minus with 6 pi h square. So that is the first order. Now the second order is this. Okay, so we have negative 12 pi h. That is our second order differentiation. And now let's solve question B from part 7a. Find the maximum value of volume V in terms of pi as the height varies. So to find maximum, we have to find the critical number first. So we have to set dvdh equal to 0. So we already have dvdh from question 7a. So we equate to 0. And now we are going to find our h. So our h is equals to a over set 3. So this is what we call as the critical number. So to find critical volume or maximum volume, we have to do second derivative test. So we have to differentiate v once again, but we already have d square v dh square from question 7a. Which is equals to negative 12 by h. And then h we are going to substitute with our critical number. So the value is negative. So confirm that it is maximum. So to find maximum volume, we are going to substitute h equals to a over set 3 into the volume formula. Okay, that is the volume formula. Now we are going to substitute. Okay, the volume formula is minus 2 pi h cube. And then we are going to simplify until we got the answer. Okay, so we multiply with conjugate to eliminate set from the denominator. And then we further simplify. So that is the final and simplest answer. Thank you.